All right, so I'm going to go ahead and fill these things in, even the benevolence here. When order is important, and we're going to use permutations. And when order is not important, then we're going to use the combination. This thing right here is called a factorial. I'm just filling these out. I'm mainly going to go over chapter 11 since that's when we had the biggest issue with. Well, I mean, it's the harder stuff. So a factorial is just a way to represent numbers where you can just go in and select one object at a time without repetition. All right, so math, probability, and it's the fourth one. Now, you know what? You got to put it in first, I believe, just like the other ones. There we go. So 40,320. So this is just plain old counting principle for times 8 times 4. 4, 8, and 4. So we're just going to multiply them all together. License plates, the same idea on the counting principle. Repetitions are allowed, so we're just going to have 26 times 26. If there were no repetitions, then we have to subtract out one and have 25. Same thing here. We're just going to have 4 tens, which is just going to add 4 zeros to 28. 6 times 26. So that license plate would have 6,760,000. This is just plain old a 6 factorial because you're just going to put them up there one at a time. So that's 120. That's 6 times 5 times 4 times 3 times 2 times 1. All right, now here's an actual genuine permutation, because you're selecting three things where order is important, because the president, vice president, and secretary treasurer are not the same. So it's essentially, so you're picking 3 out of 9. And you have that thing on your calculator for Alex. So this one right here, it's the one with repetitions. So we got 9 flags. So at the top, it's going to be 9 factorial. And then at the bottom, you've got the ones that are going to repeat, which are 3 factorial, 4 factorial, and 2 factorial. There's any number of ways to do this. I'm going to just do, you could just multiply with your calculator and do this. It'd be real easy to do that with that Alex calculator, because you could put the 9 factorial divided by, and then put in parentheses 3 factorial times 4 factorial times 2 factorial. I'm going to do it the old-fashioned way, because I don't have that calculator. All right, my 4 factorials are going to be gone when I do that. And so what I've got down here is 3 factorial, which is 3 times 2, and 2 factorial, which is just another 2. These are all being multiplied. Now, I can take 3 times 2 because that's 6 out. 2 goes into 8 4 times. So here's what's going to happen when we have those repeated things. All right. Because those flags, there's 3 white, 4 red, and 2 blue. So those are indistinguishable from one another. So I'm using that specific formula for that. All right, so this one right here is just plain combinations, because they're not talking about order like they did up here with the permutations. So this is a committee, so it's a combination, and you're going to take 3 men, and you're going to have 4 women, so 4 out of 9 and 3 out of 8. So you can use your calculator for that with that combinations thing. I'm going to do it off screen because I got a different calculator. But that one that you have in Alex works perfect for this. So this is going to be 56. And then this one is going to be 9 combinations. So times 56, 7,056. All right. Yeah, this is review for the exam. I got. Let me just show you this because on Monday, since you were still in test 4 mode, I didn't. Because I was thinking we were going to start reviewing for the exam, which it really takes 2 days, but I'm going to show you. If you go over here, the first half is already over here in the modules down here at the bottom. Hold on, there it goes. It's just taking its time. So this would be the first half of it. So now I'm trying to spend more time because that basically just went over chapters 2 and 3. I did that in my previous class on Thursday. And but as far as I got a little bit into the chapter 10 stuff, but now I want to take more time on that since that's the part where people start getting kind of hung up on things. All right, you got any questions? I think didn't you send me an email last night? Yeah. Well, I was just kind of wondering why did you waited? Because now, I mean, the final exam is you got basically like 3 days here to get ready for it, and that's a lot more weight associated with that, and it can replace that grade. So that's why I suggested doing that. I mean, all kinds of things happen when you push the date up, like for that Monday. I mean, I know I had. Technically, I probably should have had it done on Sunday so that Monday we could have reviewed, but I wanted to give you all that extra time on it. But oftentimes when you end up pushing it off, it doesn't necessarily mean you're going to get any better at it in just a day or so. All right. You doing the one online? That's probably the best one to do. I'm using this one because of the fact that I can't really. It would just take too long to kind of go through that one because you got to go from problem to problem and all that. And the way this works, I can write inside of right next to the problems. All right, so don't forget what that means. That just means the probability of B given that A has occurred. So oftentimes what you need to do is when you're dealing with and is you're going to mean that there's going to be some kind of adjustment in the second probability. Um, because what conditional means is when you do something for that first probability, it changes the set that you're dealing with, so there'll be less in it. It's like if you don't replace your cards and you pick 2 cards, then on the second pick you're going to have 51 cards, and then the numerator could also be different too. So that's what that right there refers to. Sometimes you can do these with the little charts, and the charts allow you to be able to do this using that formula that where you just count in the numerator, you put the intersection of B and A, and then the denominator, you put the number that's in A. So if they're independent, though, then there's no adjustment in the second one, probability of B. So just remember your general formulas for these. So on these, and that's all that's saying right there, is if they're mutually exclusive, then this part is going to be 0. And the only things that you do is add up the individual probabilities. And then the kind of the counterpart for the AND rule is if they're independent, then you're just going to multiply the probability of A times the probability of B. So the general formula kind of looks kind of convoluted, but so that's the general formula. So if they're independent, let's see, because so that's why this one works for all cases. Just when it's independent, then this is just going to be the probability of B. All right. So you just got to remember with sample space, that's just the possible things to choose from. And then anything less than 6 is 1, 2, 3, 4, 5. I mean, it doesn't. Oh, yeah, and that's a die, yeah. I don't see how these two are really the same thing, so I'm not going to waste any time on B. So the probability that it's less than 6 is 1, 2, 3, 4, 5. Five over 12. Because there's 12 sides, 5 of them are less than 6. All right, so this is an example of conditional. Given that the number was even. All right. So we got to look at all the even numbers. And there are 6 even numbers: 2, 4, 6, 8, 10, 12. Those are all even numbers. So there's 6 of them. So that's what determines what our denominator is, our new denominator. Oops. Now, out of those 6, which ones are less than 6? Well, there's 1 and 2. So 2 even numbers that are less than 6. Oh, okay. I'm sorry. That again, the sample space is what I just told you. Breaking it down kind of too simple for me, but that's the sample space. And so as I said, this is the 4 and 6. So that's what I did up there. All right, a bag contains 3 red, 4 blue, and 6 yellow balls. A ball is selected at random, and the color is noted. All right, so we got 13 balls in the bag. Probability of selecting a red. Well, there's 3 out of the 13 that are red. All right. Now, on this one, we got to determine about not blue. Not blue. So the ones that are not blue are 6 yellows and 3 reds. So that's 9. So there's our new denominator. Those are not blue. Now, how many of those are red? Well, there's 3 of them. So 9 not blue. And then out of those that are not blue, 3 of them are red. So this one is 1/3 too. Well, this is actually 1. Yeah, it's 1/3 as well. All right. Well, I'm recording this, like I said, so if you need some help on this one, or anybody, they can come in and look at it. Four students, A, B, C, and D, are given speeches to the class. The order of speaking is determined by random selection. The probability that C will speak first. All right. There's only one of those. So if you just rearranged them, there's only one way that they can. Hold on a second. So I think it's right. Yeah, 104. Now, so this is just talking about one pig because that's the only way that can happen. But here you got one will speak second. So there's just one where he's second. 4 different places that C could be at. So on the second one, B will speak last. Well, there's only one of those. So 1/16. All right. There are 38 chocolates in a box, all identically shaped. There are 15 filled with nuts, 10 filled with chocolate, and 13 solid chocolate. So that's 25. So that's 10 is 35. So that's 38 total. All right. So 2 chocolates in a row. So you're not putting them back in there. So this is why this is conditional, because the second one is getting affected because you're taking one out of those 13 out and you're eating it, and there's only 37 left in the total, and you want another chocolate. So you ate a chocolate, so there's only 12 left. So that's what they call conditional probability. The probability of A given that, the probability of B given that A has occurred, because A happened and it affected B. It doesn't say what to round them off to, but we'll do it to 3. So selecting caramel. So there are 10 with caramel. Now, the second one doesn't involve caramel, so there's still the same number with nuts, but there's still 37 being taken out because you've eaten one of the caramel ones. And so with nuts are 15. So that's 150. And that's the same thing that was over here. All right, so probability of A is 0.15, probability of B is 0.05. Here's a thing where you have to figure out if they're mutually exclusive or not. So 0.15 times 0.25. So 0.15 times 0.25 does not equal this. So that means then what we got to do is subtract out that amount. If this had been equal to this times that, then you wouldn't have to worry about it because it's already accounted for. Whoops, hold on a second. That's right. So let's all right. So this is the one. The probability. So if these are independent, then this over that, that's what we'll do. That's the only two things we have. Here's the intersection that goes in the numerator, and then the denominator is what follows A, which is probability A. All right, let's see. All right, so there's just a couple more here because I wanted to make sure that we got a good review on chapter 10. All right, so this is what they call the expected value. A 25-year-old can purchase a 1-year computer insurance policy at a cost of $100. Now, it helps if you have a little chart. There's not much room here, but we'll try to do it. All right, so this is, I don't have a place to put I don't have room to put a label up there, but we're going to put live here. This would be live. So this is live, and then the second one will be die. So if they live, so this is for the company, so they get $100 if you live. And the probability of that is 1 minus this little thing. Because this is a probability of dying, so we use the complement rule. All right, now for dying, all right. If a person dies, then the company pays out the net amount Can't forget that. So they're going to pay out $9,900. And the probability of that happening is 0.0. All right, so that's enough for what we need. Now we just got to multiply these down. So that's just going to move this over 2 zeros. 99, 85. And then this one's going to be negative. And then what we have to do is, just like the expected value or the mean, you just add those two up. So it's going to be $85. So on the average, they're making $85 per policy. All right, we got plenty of room here to do a couple more of this. All right, so the outcomes are 2, a 3, a 4, and then I'm going to put it over here, other. So that would be 1, 5, and 6. All right, so what happens if they get a 2? Well, they get $8. If they get a 3, then they get $4. And if they get a 4, oh, wait a minute. So there was no other. There was just 2 wins. So this is 1, 4, 5, or 6. All right, so in any of these cases, it's just going to be -1 because that's how much it costs to play. All right. Let me do something to make this a little bit clearer. So 1, 4, 5, or 6. It's just -1. Now, what I should have done over here is take into the account the fact that they're paying this one. So this would be $7 because you're having to pay the dollar to play, so you're only getting $7. And then this is just going to be 3. So those are the only 3 different things can happen. All right. So the probability of each of these is 1 out of 6. 1 out of 6. And this one is 4 out of 6. So if we just multiply it down, we'd have 7, 6, 3, 6. I'm leaving them as fractions because that's going to make them easier to add with the same denominator. So this is 10 6 minus 4 6 is equal to 6 over 6. So that's going to be $1. $1. 6 over 6 is just 1. Terrible dollar sign. So it's positive. All right, so this is the last one we'll do for this, unless somebody's got some requests. All right, a service that repairs television sells maintenance agreements for $10 a year. The average cost of repairing a television is $34, and 5 in every 100 people who purchase maintenance agreements have televisions that require repair. All right, so I'm just going to set it out. So it's just going to be repair. Well, I'll tell you what, repair. No repair. All right. Okay, so no repair just means negative $10. And 5 in every 100. So this is 95 over 100. So 95 over 100 times are going to be just collecting $10. I'm sorry. This is actually positive because they're just bringing in $10. This is going to be negative. All right. So the average cost for repairing is the negative 34, because this is from the company's vantage point that's selling the warranty. So this is, I should have fixed it up where I was going this way, but so negative 34 times 5. So that's negative 170 over 100 plus 950 over 100. So when we add these two up, we're just going to subtract. So that's going to be 780 over 100. Which is $7.80. It's positive, so that's expected profit per maintenance agreement. All right, so that's pretty much everything I wanted to hit. If anybody's got any questions about Chapter 11, I'll hit that. Otherwise, this will be in the YouTube videos under exam review 2, I guess.